Welcome to Jacket Academy Math Day 4. This is going to be the last day that we look in your ACT prep workbook. So let's pick up where we left off yesterday, which was looking at number 31. It says, to make a 750-piece jigsaw puzzle more challenging, a puzzle company includes 5 extra pieces in the box along with the 750 pieces, and those 5 extra pieces do not fit anywhere in the puzzle. If you buy such a puzzle box, break the seal on the box and immediately select one piece at random, what is the probability that it will be one of the 5 extra pieces? So if you remember earlier on in our ACT prep workbook, we had a question about probability where we said that the probability of something happening is the number of chances of that particular thing. In this case, it's the number of extra pieces, which is 5, out of the total number. And in this case, there would actually be 755 pieces because there were 755 to start with. So 5 out of 755 is the probability that the piece that we pick out of the box is one of those 5 extra pieces. And that corresponds to choice D. Number 32 asks, what fraction lies exactly halfway between 2/3 and 3/4? So exactly halfway between is another way of saying the average or the mean, and we've heard that word quite a bit in this review. If I want to average them together, I'm going to add the fractions together and then divide by 2. And so probably the easiest way to do this is by using the scientific calculator. Like I've mentioned before, the TI-30 XS Multiview actually has the fraction button on it, that when you enter the fraction, you can put in 2/3 as a fraction and then add 3/4 as a fraction, which gives you 17/12. If you do it by hand, you're going to have to come up with a common denominator for each of them. You can use a common denominator of 12. That would be multiplying this fraction by 4 on top and bottom, which would make it 8 out of 12. And that would multiply this number by 3 on top and bottom, which would make it 9 out of 12. And then adding the numerators, 8 and 9 together, is what gives you the 17 out of 12. Now be careful, because this is not my answer. I'm not done yet. I want to know the average, which is adding them together, and then dividing by how many there are, which is dividing by 2. If I have this already in my calculator, I can just do divided by 2, and I get 17/24. If I'm going to do it by hand, then to divide by that number, what I would actually be doing is taking the fraction 17/12 and multiplying it by the reciprocal of that, which is 1/2. And that's where that 17 times 1 is 17, 12 times 2 is 24. So that would be the number or the fraction that's exactly halfway between 2/3 and 3/4. Notice that I've referred to either the scientific calculator or the graphing calculator quite a bit. You are allowed to have each of those, scientific and graphing, on the ACT. So those are great resources to use, which is why you want to make sure that you're using them in your everyday classes as much as you possibly can, so that you're familiar with them and ready to use them when it comes time for something like the ACT. This next one says, use the following information to answer questions 33 through 35. So they're going to give us this setup, and then we're going to answer some questions about it. It says, Gianna is converting a 12-foot by 15-foot room in her house to a craft room. Gianna will install tile herself, but will have CC Installations build and install the cabinets. The scale drawing shown below displays the location of the cabinets in the craft room, and then it tells us 0.25 inches represents 2 feet. So here is the setup. Cabinets will be installed along one of the 12-foot walls from floor to ceiling, and 4 cabinets that are each 3 feet tall will be installed in the middle of the room. These are the only cabinets that will be installed, and each of them will be 2 feet wide and 2 feet deep. CC Installations has given Gianna an estimate of $2,150 for building and installing the cabinets. Okay, so now we're going to answer some questions about them. Number 33 says, a 15-foot wall is how many inches long in the scale drawing? So that's where the scale that they gave us comes into play, and we've actually worked a question like this pretty early on in the review. It tells us that 0.25 inches represents 2 feet. And then I want to know if it's a 15-foot wall, how many inches long will it be in the scale drawing? So I'm going to put the X inches on top and then say 15 feet long in real life. So notice once again that I've matched up inches on top and feet on bottom, or you could have it backwards. And then when I have a proportion or equal fractions, I'm going to cross multiply them. So I'm going to do 0.25 times 15, which is 3.75. And then that equals 2 times x, or 2x. And then to solve for x, to get rid of multiplying by 2, I'm going to divide both sides by 2. So 3.75 divided by 2 gives me 1.875, and that's how many inches it would be on the scale drawing. So I set up a proportion using the scale, 0.25 inches to 2 feet equals how many inches to 15 feet, and then cross multiplied. On number 34, it says Gianna will install tile on the portion of the floor that will not be covered by cabinets. What is the area in square feet of the portion of the floor that will not be covered by cabinets? So what we're saying is that in our picture, we're not going to include any of this area that's cabinets. So the length of this wall is no longer 15. I've got to take off the 2 feet deep, and so now it's going to be 13 feet long. It's still 12 feet wide, or tall, how you're looking at the picture. But then I also have to take off this section of cabinets in the middle. So first, let's find the area of the whole thing, and then we'll take off this section of cabinets. So the area of a rectangle is length times width. So I'm going to use 13 times 12. Just remember that that's going to give me the total area, which is 156. And then I need to go back and take off the area of these cabinets in the middle. So I'm going to kind of scan through this and find the part that I need about the cabinets that are in the middle of the room. It says that it's going to be 4 cabinets, so I'm going to divide this into fourths. And each of them will be 3 feet tall. That doesn't really matter to me. But they will be 2 feet wide and 2 feet deep, which means that the cabinets as a whole will take up a 4 by 4 square. So the area of that section of cabinets is 4 times 4, or 16. So I need to take off 16 from my 156. So 156, take off 16, leaves me with 140 feet squared. If I look at my options, that's that very middle one. H, 140, is the portion of the floor that will not be covered by the cabinets. So H for number 34. Number 35 says CC Installations estimate consists of a $650 charge for labor plus a fixed charge per cabinet. So what they told us is that basically they gave her an estimate up here of $2,150 for building and installing. So $2,150. And now they give us a little bit more information. They say in that $2,150, that is a $650 charge for labor plus a fixed fee per cabinet. So in this case, I'm going to say whatever the fee is times however many cabinets she's getting. So we're charging a fee per cabinet, but the question here is if she wanted twice as many cabinets, then how much would that change our estimate to? So we already know that it's always going to include that $650 fee. So if I want to find out how much they're charging for the number of cabinets she picked, then I can take off the $650. So $2,150 minus $650 tells me that they charged her $1,500 for the number of cabinets she had, however many that is. If I double that, then that's going to double the $1,500 and make it $3,000. But then don't forget that I also have to add on that $650 fee. So $650 added on to my $3,000 is $3,650 is how much it would cost if she were to double the number of cabinets installed. Okay, looking at number 36, it says, which of the following is the graph of the region 1 is less than x plus y is less than 2 in the standard coordinate plane. If you look at this inequality, it's a compound inequality, and what I want to do is break it apart into two different equations that I can graph. So if you look at this, what I'm going to do is leave the y alone, and I'm going to subtract x. But when I do that, I have to do that to all parts of the inequality. So I'm actually doing it in the middle, on the left, and on the right. And then I know that I want them graphed, which means it's going to be in my best interest if they're in slope-intercept form. And so what I'm going to do is call this negative x plus 1. That's going to be the equation on the left. And then negative x plus 2 would be my equation on the right with the y in the middle. And so what I'm saying is I want the section in the middle to be shaded. And these are going to be the two equations or graphs of the equations that I want. One of them is a y-intercept of 1 and a slope of negative 1. The other one is a y-intercept of 2 and a slope of negative 1. So I know that they should both have negative slopes. Remember that we read a line like we read a book. So if you look at choice F, both of these have positive slopes because they're going up from left to right. So that's true of F and G and H. I don't want any of those because they all have positive slopes, and I want mine to have negative slope. The second thing I'm going to look at is the y-intercept. One of them should have a y-intercept at positive 1. The other one should have a y-intercept at positive 2. And so if you see, look at that at choice J, that's what I have. Choice K has positive 2 and negative 1. I want both of my y-intercepts to be positive, so I'm going to choose choice J. Number 37 says, what is the difference between the mean and the median of the set of numbers 3, 8, 10, and 15? Well, before I can find the difference between them, first I need to know the mean and the median. The mean is the average where I'm adding all of them together and then dividing by how many there are, so dividing by 4. If I add those together, 3, 8, 10, and 15, I get 36. If I divide that by 4, I get 9. That is my mean. My median is where I line them all up, which they're already lined up, and then I find the middle number. So 3 and 15, there's one from the left and one from the right because I'm working my way in towards the middle. 8 and 10, my middle is going to be the number in between 8 and 10, which is also 9. So what is the difference between 9 and 9? The difference is 0. They are 0 numbers apart. Number 38 asks, which of the following describes a true relationship between the functions given? They're already graphed for us, so we really don't care what the functions themselves are, except to be able to tell which one is which on the graph. So f of x is a quadratic equation where your variable's being squared. That's that parabola, so this one's going to be f of x. G of x is a line in slope-intercept forms. That's going to be this line down here. That'll be g of x. And the question is, which of these statements is true? Choice F says that f of x equals g of x for exactly 2 values of x. So the equations are equal where they intersect. And they intersect in exactly 2 values of x. So that's going to be our correct solution. G says that they're equal for only one value. That would be if they crossed at exactly 1 point, for instance, like that, where they only hit at 1 point. H says that f of x is less than g of x for all x's. That would be a situation where g of x was above f of x the entire time, meaning f of x was underneath g of x the entire time. F of x is greater than g of x would be if the quadratic function was above the linear function for all x. And then f of x is the inverse of g of x, is something you see for the first time probably in Algebra 2. When they're inverses of each other, they are flipped across the line y equals x. And so in this case, one of them being a parabola and one of them being a line, they can't be inverses of each other. And so F would be our correct solution for number 38. Number 39 through 41 are asking you to use this one picture of a graphed trapezoid. It says that it's graphed in the standard coordinate plane below. Number 39 asks, what is the slope of line CD? If I look at the line, I can tell first and foremost that it's negative because, as once we said before, it is we read it from left to right and it's going down. So I know that it's a negative slope, so I can look at my options here. Then I have to know the slope formula. So what I'm going to do is use the slope formula, y2 minus y1 over x2 minus x1. And what I'm going to do is just go from left to right. So I'm going to say y minus y, which would be 4 minus 1, over x minus x, which would be 9 minus 12. And now that can go into my calculator all at once, or I can do it by hand. The top would be 4 minus 1, which is 3. The bottom would be 9 minus 12, which is negative 3. And 3 divided by negative 3 is negative 1 as my slope, which is choice B. Number 40 asks, when ABCD is reflected over the y-axis to the image of ABCD, that's what those apostrophes means, the image, what are the coordinates of the image of D? So when we reflect it across the y-axis, what we're doing is looking at the y-axis as the center, and we are looking how far away D is from that line of reflection. It's 12 units away from the line of reflection. So I would go 12 units on the other side, which would put my new D here. And if 0 is the middle, it was 12 units to the right, we're going to go 12 units to the left, which is negative 12, and it's going to stay at positive 1 as my y coordinate. So negative 12, positive 1, which is choice F for number 40, and that was reflecting it across the y-axis. If I wanted to reflect it across the x-axis, I would be counting how far it is from the x-axis and going the same distance on the other side, which would put my new D here, which would still be 12 units to the right, only now it would be negative 1 units down or in the y direction. So just make sure you know the difference between reflecting across the y-axis versus reflecting across the x-axis. The last one that we're going to look at today asks us, which of the following vertical lines cuts ABCD into two trapezoids with equal areas? So what we want to know about it is that we want their areas to be equal. And so right now, the height of each of them, no matter where I cut it with a vertical line, I'm going to just give you an example. If I were to cut it here with a vertical line, that's not a very good vertical line. If I were to cut it here, their heights would be the same. So the only true things that I would be looking at is I would want their bases to be the same whenever I add them together. So they don't have to be the same on both trapezoids. They just need to be the same when I add them together. The reason for that is because the area of a trapezoid is adding your bases together and dividing by 2 and then multiplying that by the height. Well, both of these trapezoids have the exact same height, so that's out of the equation. What I need is for the bases, when they're added together, to be the same from one trapezoid to the other trapezoid. And so what I want to do is basically find the average of the bottom and the average of the top, and then I'll find basically the middle of that. So if you look at the bottom, from 2 to 12, I went 10 units. Or I'm sorry, I'm going to average them. So I'm going to add them together, 2 plus 12, which is 14, and divide by 2, which is 7. So I want 7 to be in the middle here. If I look at the top, I'm going to average these, 3 and 9, which is 12, divided by 2 is 6, so 6 in the middle over here. And then I want basically the average of that. 6 and 7 added together is 13, divided by 2 is 6.5. So the vertical line that would make it even for both of them would be at x equals 6.5. And if you look at your options, all of them say x equals, because that's how we graph a vertical line. We want ours to be 6.5, which is choice E for number 41. Have an awesome day, Yellow Jackets. We'll see you tomorrow.